Bonjour, je suis Martine Dubuc, sous-ministre déléguée au ministère de l'Environnement et des Changements climatiques Canada. Bienvenue à cet événement. I'm Martine Dubuc. I'm the Associate Deputy Minister at Environment and Climate Change Canada. And we have this afternoon a very, very interesting event. It's our first event like this. So I'm pleased to be with you here today to discuss an important area of research that we're conducting at Environnement et Changement climatique Canada. This is the Arctic science. And for discussing this afternoon, I'm joined by scientists. We have 4 of our Arctic specialists are here with me today, ready to answer any question that you will have from YouTube, Facebook, or Twitter. So as well as one of our directors that we have somewhere with us that is responsible for the Arctic science. But first of all, I'm joined by Grant Gilchrist, Paul Smith, Jennifer Provencher, Jason Duff, and of course, they are here to have this conversation with you from a new approach, I would say, that we try to put forward to have this discussion on Arctic science. So first of all, Grant and Paul both study the Arctic birds. They are working to understand how pressures like climate change and resource development are affecting these birds in the north. And a lot of the work they do involves collaborating work with the indigenous community in the north. Jennifer studied plastic, including microplastic in Arctic wildlife. Ask Jennifer anything on her research studied as contaminant, parasite, and pathogen, but also on plastic. She recently joined me at an event. I was in Finland, and to discuss, of course, the Arctic science and the Arctic policy. Tandis que Grant et Paul et Jennifer font leur travail sur le terrain, Jason Duff, our next scientist, adopte une approche différente. Jason utilise des satellites pour comprendre comment les paysages arctiques changent et les impacts de ces changements sur la faune. Lorsqu'il ne travaille pas à analyser ces données satellitaires à son bureau, il vole souvent au-dessus de la toundra en hélicoptère. There are many others, also scientists at ECC, that contribute to this important work. I hope you have a chance to meet with them in the coming month. In the meantime, you can find ECC scientists, Phil Thomas' work in a video series that are on the YouTube channel, the channel of ECCC. So Environment and Climate Change Canada research is front and the center in the fight against climate change. When I was at the Arctic Environment Ministers meeting in Finland last month, I had the chance, of course, to speak with leaders from the Arctic nation around the world. The issue of climate change was top priority, and as Canadians, we have a duty to recognize what a changing world will mean for us. Just try to imagine what can it mean for Canada without snow or ice. Do we foresee this? We say no. We were focusing right now on the finding from the recent IPCC report, the 1.5 degree and we found this report found that the Arctic is projected to warm between 2 and 9 degrees Celsius by 2100, decreasing the amount of permafrost in the northern hemisphere by 20 to 35%. Quite an amazing impact for the people that are living there. L'Arctique est un élément clé de notre identité nationale en tant que Canadiens et Canadiennes. Même si beaucoup d'entre nous n'auront pas l'occasion d'aller visiter l'Arctique ou le Grand Nord, nous avons l'obligation de faire tout ce que nous pouvons pour protéger sa beauté pour les générations futures. C'est pourquoi le travail de ces 4 chercheurs est si important pour nous. Leur recherche nous aide bien sûr à prendre de meilleures décisions sur la façon de préserver et de protéger l'Arctique canadien. Je suis fière de dire que ces chercheurs ont aidé à entretenir également des relations très étroites avec les peuples autochtones vivant dans l'Arctique. Ils ont fait un excellent travail dans la promotion de la collaboration avec les communautés autochtones et la prise en compte de leurs connaissances dans nos stratégies de conservation. Ce n'est que par la coopération et la cogestion que l'on peut conserver ces écosystèmes beaux et fragiles. And now, without further delay, I will hand it off to our moderator, Annie, and our panelists, and I know that they all have some pretty amazing story to tell you. And thanks again to our panelists and to the audience that are with us from the different social media platform to be with us and try to have this nice conversation this afternoon. Merci à tous les gens qui sont en ligne avec nous et je vous invite bien sûr à écouter nos scientifiques et par la suite à poser vos questions. Et je demande maintenant à Annie, la modératrice, de modérer ce fameux premier panel. Thank you again. Merci à vous tous d'être avec nous.
Merci, Dr. Dubuc. Thank you. I'm Amy Black. I'm very pleased to be moderating this Ask a Scientist edition today. It's the Arctic edition, and we have great panelists here. We're about ready to get started, so feel free to write your comments in the comment box. You can ask questions in either French or English, and we'll pose them to the Arctic scientists that are here on the panel today. We're streaming live on Facebook, Twitter, and YouTube, and we'll be answering questions on all three of those channels. I'm going to kick the panel off with a question to Jason Duffy. Jason, we have a question who came in from Bianca on Facebook. It's, what's your favorite part about working in Arctic science? And there's a second part to that question. Is it very different from working in other science fields?
I don't know. I mean, I feel very privileged to be able to work in a scientific field and work for Environment and Climate Change Canada. Working in the Arctic, it's I don't know, especially under climate change projections, it seems very real. It's very important to get this work done, to get baseline information so that we can show how things are going to change. As Madame Dubuc mentioned, I do quite a bit of work in satellite image interpretation and looking at that. And the nice thing about that is we have 30 to 40 years of data that we can go back and look at that's archived, and it allows us to look at you know, how things were in the past and project how things might change in the future. And that's one of the things in terms of differences between doing science in the Arctic and doing science in different areas. I would say two things come to mind, and one of them is about satellite imagery. You know, most people know, I think, that there's a lot of the time in the Arctic that there's no light. And one of the types of satellite that we use is called an optical satellite. That is like a, you know, big fancy digital camera in the sky, and it takes pictures, so that it has to have light. It has to have illumination from the sun, and that's how we get the information. But when it's so dark up there through the winter months and fall and the shoulder seasons as well, we don't have that much opportunity to get the imagery year-round as we might have in the southern part of Canada. And I think the other major difference in doing Arctic work is just the logistics and the challenges in terms of moving around. It's expensive. There's no, you know, we take for granted in the south that we can, you know, get in a government truck and drive to our field sites. Well, you know, we can't do that in the Arctic. We need to take helicopters or airplanes or some other type of transportation. So it makes things a little bit different, you know, more difficult and more expensive. Thanks for the question.
Great. Thanks, Jason. The next question is sort of leading off of your question. I'm going to ask Jennifer. This is from Sean on LinkedIn. What are some of the key challenges you face when trying to communicate the relevance of your research to various audiences, including colleagues, stakeholders, policymakers, or the public?
Yeah, thanks. That's a great question, and one that we work at all the time, because as many of our audience members know, the Arctic is quite big and very few of us get to travel there, and yet it's a huge expanse of Canada that most Canadians will actually never get to see. And so one of the challenges is really reflecting how the Arctic is a little bit like a canary in a coal mine, and it can indicate changes in the Arctic or in the climate that we may not actually be able to see as well or in the same way as we do in southern Canada. And so that's one of the things that we work at with my group and try to really compare it to things and link it back to some of the work that we do in the South. And so, for example, as Dr. Dubuc said, I work on plastics. And that's actually one, you know, that's a challenge in Southern Canada. It's a challenge in Northern Canada. And so really thinking about how we can link the issues so that they're not Northern issues or Arctic issues, but they're issues for everybody, no matter where you live. And so we work hard on exploring those themes and making sure that everyone can understand the problems and see how it relates to their life as well.
Yeah, that's great, Jen. Thank you. I have another question for Paul here from Christian on LinkedIn. Christian has asked, how are local Indigenous communities adapting to climate change in the Arctic, and are there any specific governmental programs dedicated to working with these groups to adapt? while still protecting their cultures?
Yeah, I would say that's a focus. I mean, certainly as people online and viewing will notice, that's a real focus of this government, is to engage with Indigenous people and involve them in work. And so rather than specific programs, I would say a general approach is emerging now, which is a really fantastic thing for folks like Grant and I, who do a lot of work in the North, to see this sea change where people are recognizing the importance of working in a meaningful way with Indigenous people. It's really fantastic for us to see. So in terms of some specific examples, you know, we have some projects where we're working with people in Coral Harbor and in Arviat, for example, to build capacity to do research, for them to do research themselves on issues that are of importance to them. So we've designed questions in collaboration with the people in these communities. We've helped to collect the information, and now we're working as a team to bring that information to decision makers and try to implement some of the recommendations. In this case, it's an issue about an abundant species, the snow goose, and how best to manage it. And so, you know, that's an example of concrete ways that we're working to build capacity and you know, pave the way for a future generation of Indigenous scientists to be leading these research questions themselves.
Thanks, Paul. I have a broader question for Grant. It's sort of a bigger picture question from Anuya through LinkedIn as well. So Grant, what are some of the most unexpected things you've discovered while working in the Arctic?
Well, the challenge that's been mentioned already is the magnitude of the geographic size of the Arctic means that we can't be everywhere at once. And especially when you consider the seasonality of what occurs in the Arctic. And so what's exciting in terms of, and Environment Canada is often a leader in this, is tapping into a diversity of sources of information. Everything from satellite technology to Indigenous knowledge and points in between. And that's been very exciting because, as you can see, there's a handful of us actually conducting and leading science in the Arctic, but we are increasingly tapping into Indigenous communities that are distributed throughout the eastern and western Arctic. And so some of the most exciting discoveries of environmental change have actually been reported to us and first identified by people living in the Arctic. Now, that's not surprising, but it's exciting to think that we are now linked with people both in person, sharing field camps together, traveling together in the Arctic itself, as well as tapping into social media platforms like Facebook, where I've had the experience of polar bear hunters, Inuit polar bear hunters, coming off of the sea ice and Facebook communicating with me in real time, telling me about what they've seen. And some of the most exciting discoveries and some of the most surprising things really speak to how rapidly things are changing. So I've had a career of about 25 to 30 years, which seems like a long time. I'm told that often, but in terms of environmental change, to consider how rapidly sea ice is changing in the Arctic and that it's detectable by satellites and by Indigenous people living and hunting in the ice, to me is a shocking revelation. And now we're studying how, for example, changing sea ice conditions are affecting wildlife as well as hunting opportunities for people. So it's the rate of change, and that someone even in a fairly short career can detect and quantify change is striking to me.
Very interesting. Jen, do you want to add to that?
Sure. I think, again, just speaking to trying to understand and linking southern Canada and northern Canada, one of the strangest things I've ever found is actually some of the plastics that we find in wildlife stomachs. And so part of my research is we open up stomachs of wildlife with hunters, birds, fish, marine mammals, seals, and there are some of the strangest things inside their stomachs. And we know that some of this stuff is from communities, just, you know, local litter that happens to be in the environment. But we're also finding tons of plastic that we know is actually from the south. And we've actually found little tiny nurdles or pellets in bird stomachs in the north. And we know that they come, you know, they fall off ships and they go into the water and they float around, but we also know that there's no shipping lanes through the Arctic. And so we're finding things in bird stomachs that we know are not kind of from the Arctic, of the Arctic. We find cigarette butts, we find bottle cap lids, and so it really is like you open up a stomach and it's, you know, it's like a box of chocolate. You never know what it's going to be like in there. And that is actually one of the most interesting things that I find on a day-to-day basis working with some of the Arctic hunters.
That's interesting.
I can elaborate on that as well, just because your question was about unexpected things, and this isn't necessarily unexpected to an Arctic scientist, but what might be very unexpected to people in the South is that the levels of pollution as a consequence of emissions in the South and also in other countries, for example China, a consequence of this pollution elsewhere is being magnified in the Arctic. So the pollutants travel to the north, and then the levels that we see in wildlife are in many cases higher than they are in the north. They're higher than they are in the south, which is a surprise to many people, I think. You know, it's a very clean environment. There's communities distributed throughout the north, but it's not heavily populated, and yet the levels of pollution in some of this wildlife are much higher than you would find in and around Ottawa, for example.
And I think that links back to what Jennifer was saying about, you know, the Arctic acts as a canary in the coal mine for Canada and the world, really.
Yeah.
Paul, since you have the microphone, I'll ask you, quels seront les défis les plus importants au cours des prochaines années pour les oiseaux marins de l'Arctique?
OK, oui, merci. Yeah, Grant a parlé des changements rapides. Et moi, j'ai travaillé dans l'Arctique pour 20 ans. Et dans ce temps, il y a presque 2 mois moins de glace dans l'endroit que je travaille. Et les oiseaux marins ont besoin de la glace pour concentrer les poissons. Ils chassent les poissons, les oiseaux marins. Et à côté de la glace, les poissons mangent les invertébrats. Et quand il y a moins de glace, les oiseaux marins ont beaucoup plus de difficultés à chasser les poissons. Et on voit ça dans le poids des oiseaux. Et aussi le succès pour faire des nids et agrandir les petits oiseaux.
Merci, Paul. Back to Jason here. I have a question from Danny on Facebook. Danny asks, "What's the prediction for the future? How will the Arctic look in the future?" And so, I pass it to you with your geomatics background. you get a good look at the Arctic from your satellite imagery.
Yeah. Unfortunately, we don't have a crystal ball that works really quite as well as some of the satellites that we have, but for predictions. But I mean, one of the things that we've started to see, I mean, Grant and Paul have talked about some of the changes and you know, the idea that plastics are up there. One of the things that is changing on the landscape that we see that's having an impact on some wildlife already, and it's been identified for a number of years, but the changes in the vegetation and woody vegetation, for example, is moving north. So we're seeing, in effect, a shrubification of the Arctic. So in areas where we would just have expected, you know, grasses and more non-woody vegetation, now we're seeing they're starting to be invaded by shrubs. And this is impacting a lot of, you know, has the potential to impact a lot of wildlife. I mean, one of the species that we work on extensively in our group is caribou. Caribou are, you know, along with some of the other species that we work on, are definitely potentially, you know, subject to the impacts of climate change in the short term, potentially. And this shrubification and the changing of the nutritional value of the foods on their wintering or calving grounds has the real potential to impact this. You know, similar to the seabirds not being able to fish as effectively. I mean, it's a food chain, and these impacts on the food chains can be seen, you know, a number of levels up. Similar to the contaminants, we're seeing that, you know, changes in the forage availability on the tundra could be impacting. So we expect to, I think, you know, and there are models that suggest that the vegetation will be moving north, and this is just an example that we've seen in the Arctic, that you know, the movement of shrubs. So I think that you know, the idea is that will continue as the permafrost changes and things warm up, the growing season gets longer, that the vegetation that was limited by latitude in the past will not be as limited, and then the subsequent impacts to the other areas on the food chain are the kind of things that we work on, you know, working at the higher trophic levels.
Sure, Paul, do you want to add to that comment?
Yeah, just again, you know, because we're talking about the Arctic, and just to share some interesting things about the Arctic that people might not be aware of. And one of the really unique things about Arctic climate change, everyone has heard about sea level rise, no doubt. But in the Arctic, in the eastern Arctic, because of the weight of the glaciers that pressed the land down, the land is now rebounding, and it's really, really rapid. So in the Hudson Bay lowlands, for example, it's about 1 centimeter per year. So 1 meter per 100 years, the land is bouncing back, which is, you know, in terms of geological time, that's like lightning fast. And so in the eastern Arctic, the land is rising as the sea level is rising. And so the net effect is pretty much nil. In the west, the opposite is happening. The land is sinking, it's subsiding. So that's compounding the effects of sea level rise. So you have this sort of tilt happening. And so, the effects of sea level rise in the north are a little bit more regional and complicated than they are in other places where, you've got a static land and the ocean rising beside it.
Mm-hmm. That actually speaks to our next question, which I'm going to direct over to Jen, but we have a question here from LinkedIn. What specific impacts are being noted as permafrost melts and methane escapes into the atmosphere? So I'll direct that to you, Jen.
Yeah, so from a wildlife perspective, one of the things that we are thinking about as permafrost melts is as that permafrost melts out, it's actually releasing contaminants and other gases. And so what we're seeing and what we're hoping to model and forecast into the future is actually what that's going to mean for contaminants. So as Paul spoke to, and we've already talked a little bit, there are contaminants in the north, and the Government of Canada, through the Northern Contaminants Program, does a very good job at monitoring both, caribou and terrestrial landscapes, as well as marine mammal and fish and seabirds. And so as the methane releases and the permafrost melts out, the contaminants that were kind of trapped in there are now being added to that kind of Arctic burden of contaminants. And so that's one of the things that we're really interested in. And you can imagine in some places, so for birds, they're out in the ocean. You can imagine permafrost is melting, the contaminants get released into the river, and it flows into the river and kind of gets diluted out. So it's probably not a big deal from a seabird perspective. But from a fish perspective, there are lots of colleagues at DFO who are thinking much more specific. So as you have permafrost melting beside specific rivers, those fish populations or even those seal populations or whale populations that depend on that river or the river mouth are seeing changes in contaminants. And so that's one of the things with climate change we don't necessarily think about as often. We think about there's less ice. We think about there's maybe changes in how the animals move around. There may be changes in sea level, different across the Arctic. But then there's all these kind of things that it then leads on to. And so you have, the permafrost melting, you have the slumping into the riverside. So if there's a community there, that can be a challenge, and they may have to move communities, which we are seeing in some places. But then once those contaminants are in that river, it flows down and can have effects on food webs kind of several steps away. But it is really all linked to climate change as well.
Mm-hmm. So Jen, you mentioned that, communities are seeing these changes, and it's the communities that are, really at the forefront of this. So I'd like to ask Grant a question related to your work, and how does your collaboration with Indigenous communities assist you in your research?
Well, there's several facets to this, and one is that we work in a very remote, expensive, and dangerous landscape. And we have challenging weather, coastal environments, storms, cold temperatures, and so on. And so one of the greatest contributions working closely with Indigenous people in the Arctic, Inuit specifically, is their skills, and we're often in the field together. The other thing is they are, as I mentioned earlier in this program, they are often the first to detect subtle and dramatic changes and report them to us. And that's where we really combine forces, and we have people communicating what they've seen in their lifetime, combined with our scientific techniques, and it's quite a powerful collaboration. And in one example, in terms of environmental change, we were working in South Baffin Island and northern Quebec, tracking an emerging disease that had entered a bird population. And in those field studies, the Inuit we were working with also commented on a new and emerging issue, which was polar bear predation, they were eating the eggs of ground nesting birds. And of course, bears and ground nesting seabirds have coexisted. But what was new was the timing of the arrival of the bears each spring, and that the Inuit were concerned that the bears were coming off of the sea ice earlier, and they were arriving on colonies to eat the eggs of birds earlier. And as we looked into this further, linking and combining satellite imaging of ice conditions, weather and climate data, as well as Indigenous knowledge and new field studies, all in collaboration with each other, we discovered that in Hudson Strait, the ice had been retreating 5 to 6 weeks earlier than it once had only 25 or 30 years ago. And this was forcing the bears off the sea ice, away from their seal prey, onto land much earlier. And this is where they were coming into contact with the nests of birds in ways they hadn't before. And so that storyline is really exciting to me because, first of all, some of these issues never would have been detected had they not been reported to us by Northerners. Our fieldwork wouldn't have been conducted without the input and participation of Northerners, and then we've shared in the results. We've published this in the scientific literature, we've communicated this at conferences in Finland and the Arctic Council, and it's also influencing bird and bear conservation in the north, and which is now co-managed by Inuit. So that's a very rewarding experience, and it's also exciting to be out on the land watching the environment change with the people that it also affects the most. And I'm excited to say that Environment Canada has been a real leader in this, and we continue to expand our research, and that's some of the linkages that has enabled our research to go forward. Great.
I'm wondering if Paul can follow up on that question by answering a question that's come in through Facebook from Thomas. It says, how can we reconcile Indigenous knowledge and Western science when they come up with different conclusions?
Well, I mean, it's an interesting question. And so I wouldn't say that this issue is specific only to disagreement between Indigenous knowledge and Western science. I mean, even within science, for example, there's often disagreement. And so I think there are techniques to resolve these kinds of disagreements. One of them would be to think carefully about what outcome people are trying to achieve. So if we're thinking about disagreement, for example, like population numbers, well, it might be helpful to step back and understand why population numbers are important and whether or not we can arrive at a conclusion that that suits all, a management recommendation, for example, that doesn't need to resolve that disagreement. Other ways would be to work together to design studies that can try to arrive at a common solution that both people feel invested in because they've participated in the collection of the data. So, for example, if we're interested in a population estimate for caribou that we can all believe in, then we could design the surveys together and carry them out together and then arrive at a number that we all agree to, for example. But this isn't exclusive to a Western science indigenous issue. This is an issue that scientists deal with all the time, disagreement even among scientists in terms of which number's correct.
Yeah.
And so there are various techniques to try to arrive at, at a number that everybody can agree with, for example.
Did you want to add to that, Jennifer?
Yeah, I would just add one thing, that there's actually a great example. So one of our colleagues' work is Dominique Henry, and they've been mapping out snow goose colonies, as Paul spoke to a few minutes ago. And one of the really interesting things is that they did some mapping, and I was able to participate in a meeting in Arvia with her while she was discussing the results and, doing exactly that, trying to resolve some of the differences. And the maps between the science as well as the indigenous knowledge were almost identical, except for two little kind of bubbles. And one bubble was south of a river, and basically the science survey said there was a goose colony there, but the local knowledge, the indigenous knowledge, said that they hadn't put a bubble there, essentially. And when we went back and talked to the hunters, it was about the timing in the springtime that people didn't cross that river. And so it wasn't that they said that there was nothing there. They just weren't there at the right time to be able to do something that the satellites could do at different times of the year. And then the other bubble was it was an older science bubble, but the local knowledge is much more contemporary. It's in the moment, whereas sometimes our science knowledge is 5 years. The modeling was done 5 years ago or 10 years ago, and so we think that the second kind of difference between the two was just the size of the bubble was just a mismatch in timing. But again, by stepping back and actually having that conversation with everyone at the table, she actually was able to kind of not resolve, but discuss why those differences were there and come up with two very easy examples of why those two bubbles may have existed. And we do a very similar thing in plastics, where I also almost think of it as a give and go model. We use indigenous knowledge for plastics, and so we have to take a little here and a little there, and then we weave them together, and we give and go with that data.
Perfect. I'm going to come back to the plastics thing in a minute, but I have a question for Jason, actually, and it's this actually came in. What would you say to all the young people who are interested in pursuing a career in science? And I would add to that, in Arctic science.
Well, Yeah, I mean, just I never, I feel very lucky to actually be. I never, when I was in school, in high school, really, even in university, you're not really exposed to government research, really. I mean, in university, you get to see a lot of university research, obviously. I mean, to a certain extent, you understand that your professors teach courses, and you don't, in undergraduate, you don't get exposed to it a lot. So, for myself, it was more just interacting with people, talking to graduate students, and the opportunities come up to be able to go, and I think that there's a lot more now, just with the awareness about Arctic science and the importance of science. I mean, in the last few years, it's really come to the forefront a lot more that this is an important discipline and this is important information, and we need to base policy and decisions on these on science, whether it's in the Arctic or anywhere really, and whether it's in a wildlife science or any type of decision that the government has to make. So stay in school, talk to people, get mentors. I think understand. Yeah. I think it's just working with people, seeing how people do it, how people do it well. I mean, again, obviously feel very privileged to be able to work with some great Arctic scientists in our organization, and some that have come before. I mean, I think that the Canadian Wildlife Service has had a long history of producing great Arctic scientists, and people have done very seminal work. And so I think it's just about go for it. It's possible. Again, 25 years ago, I would have never suggested that this is where I was going to end up being, and feel very happy to be here and to be able to contribute.
Yes, yeah, I absolutely agree. I'm going to ask Jen a question that's come in on Facebook from Danny, and it's specifically related to plastics and wildlife. What's the impact of plastic on wildlife in the Arctic? And what can Canadians do to reduce these impacts?
Yeah, that's a big question and a great one. So plastics in the Arctic are definitely lower than some of the levels that we see in southern Canada. So we actually use a bird called the northern fulmar, which is a bird that flies around at the surface of the water and basically is picking up things that are floating. So it doesn't really have the ability to dive down. And so it's a great species, an indicator species to use for plastic pollution or plastic marine pollution. And so we actually have been able to sample through Environment Canada, and actually really through Parks Canada partners as well, sites in Nova Scotia, through hunters in Nunatsiavut or Labrador, and then all the way up into Nunavut. And we see that some of the highest levels of plastic pollution is actually on our eastern shoreline, so off the coast of Nova Scotia. But yet we still have plastics in our northern birds. And we actually find that 85% of the birds the northern fulmars that we sample in the Arctic, have some level of plastic plastic inside their stomach. And so these can be quite small pieces, but they are big enough that they kind of sit inside the stomachs. And you can imagine that for birds that have a lot of plastics in their stomach, it can actually make them feel full. And so when we open up the stomachs, the plastics are kind of packed down at the bottom. They kind of pack in there. And for birds that have a lot of plastics, they actually can make them feel full. So you can imagine, on Thanksgiving or whatever holiday you celebrate with lots of food, right? Feeling full, and you got to unzip the top button a little bit. But for them, it's actually full of plastics. And so you stop eating, and yet you have very little nutritional intake, essentially. And so that's one of the ways that we see that plastics can affect seabirds. It's probably less in the Arctic right now because they have lower levels of plastic, but we're still finding plastic in the birds that we work with communities to hunt and find in the north. One of the things that we're really concerned about in the north is actually you have the physical plastic that's sitting in the stomach, but plastic is made of chemicals, and those chemicals are leaching out of the plastics. And so what we're really concerned with in the north, and specifically with our Indigenous hunter partners, is what are those chemicals that are leaching out into the birds If they're hunted birds, if are people, what tissues are they going to? Are they going at a rate that should be concerned to hunters? People want to know what those chemicals are. And if they're in species that are important for them, they want to know what parts of the species are also important. So there's both that physical and chemical aspect. And that's true worldwide, but that's something that we're particularly working with our partners in the north to figure out.
Great. So I'm going to ask all of you a question that's come in on Facebook from Irina. What's your favorite Arctic animal? Yeah,
wow.
That's a great question.
That's a really great question. I have to say that one of my favorite Arctic animals, and maybe it's not an Arctic animal, is actually the Arctic tern. And so I have a soft spot for birds, but the Arctic tern is a species that breeds way up in high Arctic Canada, as well as Hudson's Bay and Hudson Strait. But the amazing thing about the Arctic tern is that it actually travels all the way down towards Antarctica every summer. And so you can imagine that there's, we think of it as this Arctic species, this Canadian bird, this Arctic breeder, and yet it really is this is going to sound corny, but it's kind of this global citizen, right? And so you can imagine that it's spending time up in the north and then circles all the way down through, across the equator, down through the tropics, down into the Antarctic Ocean around there, and then it comes all the way back up. And so when we think about, and I love it because I think about bird conservation often. And when we're thinking about bird conservation, we need to take action in the north, which is where they're breeding. But to really push bird conservation, we need actions all the way along that pathway. And so I love the Arctic tern for that reason.
Great. All right. Paul's super excited to tell us about his favorite bird.
I've got an example that makes the Arctic tern look lazy. So the Arctic tern goes far, but my favorite species, the roofer red knot, it can't stop along the way to eat like the Arctic tern does. If it's flying over water, it has to fly nonstop. The Arctic tern can sit down and grab a bite to eat anywhere along the way. So the roofer red knot, it weighs about as much as a juice box, and it breeds in the Arctic and winters all the way down in the very southern tip of South America. And it will do some of those flights nonstop. For example, it'll fly nonstop from Delaware Bay, New Jersey to the Arctic. And because it can't stop to feed like the Arctic tern can, it has to fatten up and then use this fat to fly. So this bird will actually digest half of its body mass, fat, but also muscle, organs as well. It'll reduce the size of its internal organs to make these flights. And even though they're small, again, the size of a juice box in weight, they live a pretty long time. They can live 25 years. And so if you do the math, this tiny bird will fly to the moon and back in its lifetime. That's pretty amazing.
That is pretty amazing. That's pretty stiff competition, Paul. Grant?
Beat that.
I study birds, but everywhere I've worked, both in the summer, in the high Arctic, low Arctic, and also in the winter, I've often been kept, I have company when I'm studying birds out there, and the animal that's often in the area and with me is the Arctic fox. And the Arctic fox, I work on seabirds at large colonial nesting colonies, and there's usually 1 or 2 fox dens that are associated with the colonies, and the adults eat the seabirds and provision them to their kits. So there are always foxes present. They're very comical, and they're troublemakers too. But also some of the most interesting experiences have occurred with me when I've been working in the winter. So in the winter in the Arctic, I've been at the floe edge, or I've been at polynyas, which are small areas of the sea that stay open because of strong currents. And I'm there to study birds, but there are always foxes present. And sometimes our work out there, we're out there alone. We're sometimes cold and miserable, and sometimes to have another animal that looks completely comfortable and at ease is reassuring. So I like the Arctic fox, and they have some amazing behavioral traits in the Arctic. And there's a great research team at the University of Quebec, Rimouski, who studies Arctic foxes and tracks them by satellite. And so for more information on Arctic foxes in the Arctic, I recommend you go to the Rimouski websites to learn more about them.
All right.
Well, I'm going to be cliche. I think that my favorite is the polar bear. It was actually my first job when I got hired. After my undergraduate, I got hired by a research scientist in Environment Canada to work on polar bears and heated contaminants. At that time, it was the sort of more old-style contaminants, the PCBs and organochlorines that had been, at that time, they'd been taken out of production, but they were still being seen. And anyway, so I mean, it's a majestic grand animal that I had no formal education on it. Didn't really know anything about it other than the grandeur of it. But then when I started working with this research group, just understanding some of the incredible, same as you guys, the incredible life history traits and the things that the polar bear goes through in terms of, having its cubs while fasting for, a number of months through the winter. What kind of animal, can do this kind of thing? How does that make any sense? And then at that point, from a contaminants point of view, there are these amazing machines, right? The profile of chemicals that go into them is very different than the ones that you find into them. So for some reason, they have developed this incredible ability to be able to change the chemical, to metabolize and change the chemicals in their body. So I still, my first foray into Arctic work was on the polar bear. So I would say that's my favorite. I don't have a pet research animal. We work on a number of animals across the Arctic, but polar bears always remain my favorite.
Great, thanks, Jason. I just want to remind everyone out there that you can post your comments in the comment box below in either English or French. And maybe you want to tell us what your favorite Arctic animal is. See if you can beat the flying juice box. Or So I'm now going to ask a question that came in from Sadia on Facebook, and I'll put it out to you guys to choose who would like to answer it. It's, what inspired you to pursue Arctic research? And I'm sure you all have a story or a person who really influenced your career in Arctic science. So would anyone like to?
So it gets back to also the point about would you encourage a young person to pursue science? And there's some good, we each have our own story. And like Jason, I actually set out to be a high school teacher. And along the way, I was strongly influenced by a professor at Trent University named Erica Knoll. And she taught ornithology and some really great courses. And she's very passionate about nature, and she encouraged me to go further. So this speaks to being mentored by somebody. And she also introduced me to an Environment Canada research scientist named Tony Gaston, who had a long career with the Canadian Wildlife Service and Environment Canada studying seabirds. And I just wanted to go to the north. I didn't care whether it was studying lichens or mosquitoes or whales or birds. I just wanted to get north. And so she put me in touch with him. And the first time I went to the Arctic, we couldn't land on the beach because there was a polar bear that had swam ashore. And then when we did get ashore, we lived in a remote field camp at a seabird colony with Arctic foxes and bears and walrus and so on, and I was hooked. And my story is one of, you don't really necessarily set out in this direction. I had a passion and an interest in nature. And now I feel excited to contribute generating information that is interesting and relevant to Canadians. And because Canada is a leader in Arctic science, and we have so much of the Arctic, and also its interactions with Indigenous people, we have the potential to be a leader there as well. It's a very exciting time. So from humble beginnings as an undergraduate university student, then introduced by Erica and Tony to the Arctic, that's how I got my start. And it's really easy to maintain a career where you really believe in what you're doing and the organization you work with and the colleagues you work with. And the number and diversity of people that my career has introduced me to, from Inuit polar bear hunters to politicians and policymakers and the public, has been a very exciting.
Great.
I can build on the common thread there, because my introduction to the Arctic was through Erica Knoll as well, as Grant knows. And so, I had done this fantastic summer job in Algonquin Park working with Erica on forest birds. And so that's sort of the proving grounds. Usually technicians that come to Arctic field camps will do a little bit of work first to sort of test their stuff. And then the ones that can hack it will be invited to go north. And so, building on that question about what students can do if they're interested in work in the north, one of the commodities we're looking for are well-rounded people who have the ability to be out there on the land taking care of themselves. So someone who likes science but also knows how to fix an engine is a rare commodity, right? And so anyway, I did this work with Erica Knoll as well, and then was invited to go up to the north the following year, and I've been doing research in the north every year since.
Great.
Yeah, so just to build on that, I have a very similar story to actually Grant, and I actually similarly really wanted to work in Haida Gwaii, and Tony Gaston, who was a long-term Environment Canada researcher, had a program in Haida Gwaii on seabirds, and I had studied whales at that point, but I always wanted to go to Haida Gwaii. But after 2 months of working in Haida Gwaii, Tony figured out I could sleep in a sleeping bag and fix an engine and count birds all at the same time, and got invited to go to the Arctic. And I've been going back ever since. And so speaking to the question of what do you do, I think really, following people that inspire you, working hard, and making sure that you love it. Because it's not always easy. It's not always easy being stuck in a cabin for 4 days because there's a storm. It's not always easy planning and doing logistics. So if you love it, do it. And if you don't love it, that's okay too.
That's fantastic. Okay, so we're going to move on to the next question, but I'd like to ask Jason, can you tell us more about what it's like flying over the Arctic tundra in low-flying aircraft?
Well, I mean, it's pretty fantastic, really. I mean, it's I think a view that not many people get to see. I mean, in my group, we do most of that work around coastlines. So we map coastlines from helicopter videography. So we have a method set up where we have 2 people in a helicopter, and we fly about 300 feet above the coastline, and we take video of it, and then we interpret it back at our lab. And I mean, it's, we sometimes take these videos to community events and to some trade shows, some areas where Environment Canada has a booth set up, and I mean it's that we're always a big hit. When we had our open house at the National Wildlife Research Center, I mean people, it's just an advantage that you don't get to see very often, and even in the communities, right? Yeah. The communities don't get that view either. I mean it's kind of like it's anything, right? Google Earth. I mean, it's, maps are easy to look at. It's very easy to understand. Same with, once you get looking at satellite imagery, it's like, wow, all the stuff that you can see. Well, you can imagine being just 300 feet over it and getting to see all of these, fantastic landforms from these, giant cliffs like, these guys work on and the bird colonies to, for example, in the Mackenzie Delta where you might have, as far as the eye can see of mud flats and wetlands, and it's, yeah, it's pretty amazing.
Perfect. So I have a really interesting question from Dennis on Facebook. Jen, I'll have you answer this one. Okay, here's the scenario. You come back from a long trip out in the field. You just got off your plane, absolutely famished. We've all been there. What are you craving?
Ice cream.
Ice cream. That was easy.
Ice cream every time. We've been in lots of camps. We eat very well a lot of the time. Ice cream is not something that we can ever keep well in a camp. Yeah. Ice cream.
That's great.
If it's month 2, then it's a salad that's not made out of cabbage or turnip.
Yeah. All right, we'll pause the imagery there. I have also another really great question from Julie on Twitter, and I'll ask Paul to answer this because you have the microphone. What is your Arctic science superpower?
Wow, okay. Huh. Well, it's changed actually now that I'm getting a little bit longer in the tooth. There was a time when my Arctic science superpower was being able to hike nonstop all day. So the kind of work that we do, we're looking, if you can imagine, we're looking for a camouflaged nest that's about, not even as big around as a tea saucer. The eggs are maybe 2 centimeters across. And they're designed to be perfectly camouflaged, and they're hidden in the grass. And there's, on the order of a half dozen per square kilometer sometimes. And so this is what we're looking for all day. And so it takes a lot of hiking. Yes. And so that was my superpower. Now my superpower is fishing.
I thought you were going to say your superpower was finding the nests. But
no. There was a time that I've been used to it.
Anyone else have a superpower? Grant?
Sleeping in a tent in 24 hours daylight.
Yeah. Yes.
Like a lot of people struggle with sleep issues and so on, and I can sleep anywhere. I've slept under a Zodiac, I've slept in floater coats, and I've slept on aircraft. I slept in a helicopter that had run out of fuel. Slept in igloos, so I can sleep pretty much anywhere if I'm tired enough.
Sleeping superpower. I like it. Yeah. Jen, you have one?
I think one-pot meals. I can do almost anything in a one-pot meal, and a lot of our camps are very simple. There's sometimes not a lot of water. We don't want to do a lot of dishes, but you're hungry and you want that warm meal. And so I think I would say that I can cook up a lot of really good meals in a single pot. And feed people, 10 people who have been working all night really hard on different projects. So good, big one-pot meals.
Yeah. Jason, do you have a superpower?
I don't think so. I'm just going to represent the mere mortals.
That's great. Well, I have another question for you. So this came in. What has surprised you most about the Arctic landscapes and how they've changed over recent years?
Well, I mean, these days I don't spend much time in the Arctic myself, and like this has already been mentioned, we spend a lot of time looking at the Arctic from space. And I think that, as I talked about before, the big thing that we've seen is the real changing in the vegetation. One of the projects that we're working on now is also on lichens. So trying to be able to see lichens and look at how lichens have changed through time. So we see this change from this sort of grass-based lichen to more of these woody, where the tree line is moving and we get more shrubbification and changes in those ecosystems. So from our vantage point, from sitting in our lab in Ottawa looking at the Arctic through space, those are some of the biggest sort of changes that we see.
Mm-hmm. Jen, I have another question for you that came in through Twitter from Larissa. What do you wish you knew as a young scientist? And this, we have a lot to say to youth and young scientists in particular.
Yeah.
What do you wish you knew before embarking on your career?
I think that one of the things that I didn't get, because I think it's some ways hard to communicate, but I didn't get it as a young scientist, is how many questions there still are to answer and how many things that people can do. So, we can sit here and talk about all of the things that we know from birds and from Indigenous knowledge and contaminants and satellites, but there are so many questions, and I think I probably speak for the group here that for every question that we answer, we're left with 3 more. And that there are so many things that are happening and emerging in the Arctic in terms of how we weave together knowledge systems, on how we can adapt communities in the north and in the south to climate change, how we can bring together partners to address questions of conservation, habitat protection. I work on plastics, which is an emerging concern. There are so many questions out there. And so it may seem like there's lots known even about the Arctic, but there's so much more to know. And I try to encourage the young scientists that I work with that, again, do what interests you, follow your passion, and there are things for you left to do, many things for people to do. And so I really encourage, and I wish I knew that a little bit more as a young scientist, how much we didn't know. And so I think that's just one thing I really like to stress with people.
Great, thanks, Jen. I'm going to direct the next question that's come in through LinkedIn from Victoria to Paul to answer. How can the public direct their efforts in improving the environment?
Sure. I suppose, we've talked a lot about trying to find your passion and follow your passion. So there are lots of ways that people can help the environment. And I would suggest that people find one they're passionate about and then devote themselves to it in a meaningful way. So whether that's passionate about reducing your amount of plastic waste so that you're not contributing to this, this ingestion of plastic among Arctic seabirds, for example. Some people might be passionate about, migratory birds, and there's loads of ways you can participate in a meaningful way in science. So, for example, I study a type of bird called the shorebird. It's a group of birds, like killdeer would be an example that many people would be familiar with. But in the Arctic, there's quite a lot of species of shorebirds. If people are interested in these types of birds, they can contribute to monitoring programs. For example, the Ontario Shorebird Survey here in Ontario is the way that we track these populations, and we're always looking for volunteers to go out and participate in this. The Breeding Bird Survey is another example for a different group of birds. And so there are meaningful ways for people to get involved in science, and also meaningful actions that people can take on a small scale that collectively can contribute if they find what they're passionate about and then devote themselves to it.
I think you make a great point about people, you can do things in your own backyard. You don't need to be a scientist who travels to the north or anywhere else. You can actually contribute where you live in Canada, and that's a great message. Thanks, Paul. The next question is, I'll give to Grant. Grant, you were a member of Canada C3 last year. Can you tell us a bit more about what it is and what your experience was on the boat?
Canada C3 was a nonprofit expedition that was part of Canada's 150th celebration, supported in part by the federal government. And its intent was to bring together Canadians from the arts, Indigenous, youth, and science, all on a ship that was a retired Coast Guard ice-class Coast Guard vessel, and it went from coast to coast to coast. It left Toronto and then traveled east into Atlantic Canada, then up through the Arctic, through the Northwest Passage, around Alaska, all down through the west coast of BC, and it ended its trip after 150 days in Victoria. And both Paul and I were very fortunate to be participants on separate legs of the expedition. It was a very, really actually a career highlight of mine, because the people on the ship were such a diversity: athletes, musicians, poets, scientists, some very exciting and inspirational Indigenous youth and elders, all brought together, and we really conversed about what is Canada and where are we going and how can we do this as a community. And the tone of the ship, and it was the expedition leader was Jeff Green of Students on Ice, and he's a fantastic guy, and he was one of the visionaries behind this expedition. And if people would like to see more, there's a lot of, if you go to the website, there's a lot of videos and a lot of interviews, because the ship is really this floating community of talent that was really interested in issues such as this: climate change, social issues, Indigenous reconciliation. And a lot of the discussions and conversations and photography and so on, the experiences of this expedition have been captured in both videography and a new book that has just been produced.
Thanks, Grant. I have a question for Paul. We'll send the microphone back that way. It's from Ted on YouTube. How do you personally deal with the increasing amount of alarming findings on the future in the Arctic?
Yeah, I mean, so I mentioned that this group of birds that I specialize on in particular are the shorebirds, and these species have declined on average, by 3/4 since the 1970s. So many of these species are potentially headed for the endangered species list. And so this is troubling. This is a group of birds that I'm trying to understand the cause of declines for, and I'm watching them disappear. I've noticed the changes just in my career. I've noticed the changes in the sites where I work in terms of the abundance of these birds, and trying to understand, how and why these species are declining. So that motivates me to really focus my efforts on trying to understand this issue, trying to do what I can to reverse it. And to me, that's a major motivation for why I'm passionate about my job and take great satisfaction in being involved in trying to solve this issue. But it is alarming. I mean, it really is. And it's important to stay focused, and to the extent that you can, positive on trying to find solutions.
I like that message of positivity. Did you have something to add, Jen?
Yeah, I'll add. And I think that's a great question, and I think that's a question for Arctic scientists. I think it's a question for Southern scientists. And one thing, working on plastics, we think about that a lot. Amongst the scientists who study plastics, we often talk about, have you looked somewhere that you haven't found plastics yet? Not really. We keep looking in new species, we keep looking in new habitats, and we keep finding plastics. But one of the things that I take the most positive outlook from is that plastics, like climate change, we actually can all do things at home, and that's really what we need to focus on.
Perfect. Those are great remarks to close on. So I just want to let everyone know that if we didn't get to your question on any of our social media channels, we will attempt to answer them after the event. Thank you so much for asking those great questions. I'd like to welcome Dr. Dubuc to give us some closing remarks now.
Thank you. First of all, Jason, Jennifer, Paul and Grant and Amy, thank you so much for the science that you are doing. Thank you so much to be also a part of our ECCC department, Environnement et Changement climatique Canada. The work that you are doing, you just share that with the public, is fantastic. You bring a lot to the country. Vous apportez beaucoup à la science que vous faites, que vous partagez aussi avec les citoyens aujourd'hui. Ça prend souvent beaucoup de détermination et de courage dans le volet scientifique, and you have it. So again, we are really proud of the work, and we are really, really lucky to have you in our department. Thank you so much to be with us, and thank you to you, Amy, to have do this coordination of this discussion, and thank you for your science also, because you are a scientist also, and we are really proud of the work that you are doing for the country. Merci à vous tous. C'est vraiment une chance pour nous à l'environnement de partager avec vous aujourd'hui. Merci d'avoir accepté l'invitation. Et merci aux gens qui sont en ligne d'avoir été avec nous aujourd'hui. Thank you. And it was our first, but not the last one. So we'll come back to you to say, let's talk about science in the future. And of course, we want to have the young scientists coming in our department. So hope that it gave you a taste of the good work and the good science that we're doing in our Environnement et Changement climatique Canada. That is quite important. Thank you so much. Merci.